Hello. Thank you all for the warm welcome in Vilnius here today. This is my first time in this country, and I'm amazed how welcoming everybody is. I hope you had a nice lunch. We're going to have a lightweight session right now. First of all, my name is Ana Baotić. I come from a country called Croatia. We're a little bit downward to the south. We have lovely coasts, and we had Game of Thrones here, if that's a show you liked. Now, I need to make a confession first. I'm from the other camp. I used to be a developer, mostly Android. So all the myths and horrible things you heard, they're somewhat true. We don't play well generally in our start of development with QAs and testers. Just one show of hands, are there any developers here today? Oh, a few. Okay, let's continue then. We will be covering pen testing and reverse engineering Android apps, but first we will cover all the things we can do while developing to make them better. And I think that the QA team and testers in general can help developers a lot in making a better product. So this is how we're going to do it. Our agenda for today is first code coverage and what should be done as a minimum every time your team develops. After that, we will cover how to analyze and get the APKs from a device if we need to do that. We will cover most useful and simple tools you can use basically without any knowledge in order to help your team test their apps. And we will going to come to a conclusion after all of this. Now, first and foremost, the things that we do is cover things with static analysis. So basically general tools that are used to improve code quality. Now, we do this because 2 years from now, we're going to hate each other when we look at our code and think, oh God, why did I do this? Why didn't I make this better? Why didn't I make it modular? Why didn't I put a little more thought into the architecture of the project so I can make it easier for me and my team later on? So those are the things that need to be done in order for us to have a happy career at our company. If your code base is going to be inherited by somebody else, then you need to be kind and think about them and their work in the future. Some of the most common tools are PMD, Findbox, and CheckStyle. They basically make sure that the things you write are written in a clean manner. For instance, if you hard code value 4 for a text field and you just leave it there and you need to change it somewhere, but you referenced it somewhere else, then it can be very painful and you just generate work for yourself and your QA team, which we should try to avoid. The next thing you can do with your codebase is include lint. So those are very annoying, persistent warnings on things that are not okay with your codebase. For instance, if you're using something obsolete or something that's kind of problematic, one example could be source random, where you get a warning that what you're using isn't quite up to the standard. And it also shows severity and how much of an impact on your code base it actually has. So this is 9 out of 10, so it's big. Now, once you've got those simple things down, you could probably venture into something more elaborate, like adding kind of a library or an SDK or maybe some kind of add-on for your Android Studio. That's basically the tool you use to develop Android applications. And most of those tools are free. Some require subscription, but DevNox is one of them that was very convenient in terms of you just include it in your workspace and you get warnings on stuff that's incorrect. It basically goes through your code base and your build and says, okay, you have an issue here, you have an issue there. Things that you might have overlooked or missed or maybe you didn't know could be a problem. One example for that is a dummy project that was, used to be just develop random things and test out libs. Here we have 84 warnings. Some are less important than others, but there's one very interesting here, and that's the tab jacking attack. If you haven't heard about tab jacking, it's basically a problem where you have an overlay on your app and some malicious attacker or application is basically stealing the input that you make on your phone, which doesn't seem, all that critical, but if you're using your banking app or your social media account, then that could lead to bigger problems, like your pictures being leaked out or information stolen or money lost. And people tend to like money, so that's kind of a thing to watch out for. Of course, the reference to JavaScript, that's always, like very warm topic to discuss. JavaScript tends to open doors for bigger issues, and it's generally discouraged in terms of Android applications, especially when you do native. You tend to not use web views anymore, which were used to show URLs and HTML. So yeah, basically warnings that you can look out for. What I found out recently, as with all things that sound good, they're no longer supporting DevNox officially, and it's supposed to go open source. Now, this message is probably there for a year and a half, so they're either still thinking about it or haven't found, I don't know, people to work on it. But yeah, it happens in life, especially in software. Tools you like get obsolete and not changed for anything else. Now, there were a lot of sessions already, and there will be a lot of sessions here about automated testing, and you should go to them and listen to why it's important, or how they help people produce better, faster, and more reliable. I don't think there's any, weight in telling you why it's important. It's just something that makes sure that what you do and what you create works consistently. For instance, you add a new feature, a new page in the application, you show pictures of cats, whatever it is, doesn't matter, and suddenly login breaks and you have no idea. Why would one influence the other? So automated testing makes you think about the code, and if you cover your code base with tests, then you know that it will break before you actually publish to the store, because one person knowing, two people knowing about the errors that were introduced is much better than 100,000 of your production users, although that happens as well. But later on about that. And the most important part from my perspective as a former developer is having a QA team. Now, you can create anything you want, but unless a human person out of flesh touches your application and tries to use it, it's useless. You can hide behind the emulators, the virtual machines, everything else, but you need to have a person take the app, try to use it, try to work with it, and that's when you actually get the concrete feedback, whether or not if it's okay or it's broken or it's not working. And more important, you need to test on physical devices. Now, again, developers love emulators. They will create an instance for each SDK that Android produces. They will run their code and they'll say, okay, this works awesome, let's just ship it out. But when you install it on a Samsung device, it doesn't really hold anymore, because each vendor kind of modifies the SDK, and Samsung is notorious for that. So you need to use real devices. What you can add to your process as well, especially for Android, is to use Google Play Beta and Alpha. Basically, you have the option to release your APK to a small set of users through the Google Store, where they will get the upgrade through that store. So it's a normal process that will happen when you publish it, but also it's tested on devices. They have like a test that will distribute it, and they will give you a report. Now, this is very useful because it can show a trend for each build that you create, what were the issues with it, how it looked. In this particular case, when you submit it and you get that report, you will get a 5-minute recording of your application. You will have screenshots for 10 various devices and how it looks. So if you're not sure if you optimized for different resolutions and screen dimensions, this is the part where you can take a look and confirm that it's okay or it isn't. And most importantly, when something breaks, this will be the next line of defense to stop that problem from going out to your users. Of course, when you do get to production, and developers with more experience have seen problems like this more often, it's useful to have a reporting tool that will cover those situations. Okay, something is trending, something is broken, we need to take, I know, some kind of action and check and maybe stop the release and publish a new fix immediately. And it's really useful because, sometimes you cannot wait for the business hours to come and for the users to start calling you and your managers and saying, oh God, you broke everything, nothing's working, we don't like you anymore. So having a tool like this is very useful. Some are commercial, some are free. It's free to choose, of course, which suits your company better. But also, again, common sense is often misplaced in the whole process. For instance, this was an actual occurrence in one of the applications in a company I worked for. So we got a velocity report that something is horribly wrong with the build. And when we investigated, and again, you need to investigate, not just say, okay, everything has gone to hell, we need to pull it. If you take a look at the data here, you see that it's one device, 100%. So this is a good number. That means you have isolated the issue. But even better number than that one is basically when you take a look at how many users are having a problem. So this means that one person on one device took the application and just repeated something 219 times. So these are your users. This is the production. Somebody will say, okay, let's just repeat this action and get crash after crash because it's fun. Maybe they didn't have anything better to do that day. Maybe they were just bored. But basically, this is your fan base. And that's also something to take care of. So easy to fix in terms of locating the device. But as for the user, that might be a bigger problem. So the Android ecosystem is very diverse. By diverse, I mean it's chaotic. So if you want to test on physical devices, I can assure you, you won't be able to test on all. So this is a snapshot of all the screen sizes and resolutions from, I don't know, 2 or 3 years back. In that time, there have been countless more added. The industry is expanding. It's on other continents. They're mass producing devices because Android is open source and creating for Android is cheap. And not everybody can cash out $1,000 or more for an iPhone each year because it's courageous or wonderful or the best iOS device ever. So this is your ecosystem on Android. Now, if we want to test all the things I covered, basically those are something we should be doing by default. So it's a lot, but in the long run for your company and for your team, it's simpler to do it. If you set up the system correctly, you have fewer problems onward. But we can also take a look at the apps from the outside in, and not just our apps, other apps as well. So what's typically done when you produce a build, especially if you're working for the fintech industries or banks or I don't know, other ventures that deal with money, they will ask you to penetrate your apps or to harden your apps or basically to reverse engineer them to confirm that you're not storing something, critical inside that could be taken. So pen testing is basically an authorized simulated attack on your app or any other system that might be out there. And this is very important because, like I said, you might be having or storing something in your application like an API key for Google or, I don't know, a session token, something that you might not have thought about in the beginning of your project, but can cause physical harm to your users. So the motivation, because it is obviously security, you need your apps to be secure as possible. You need to assure that your users are private. So if you're posting conversations, if you're having conversations with your colleagues, if you're sharing images, you want them to remain within the scope of your conversation, not leaked somewhere, data mined, and whatever. We have seen far too many exploits recently to take it for granted. And finally, like I said, mandated by industry. Banks have a legal requirement to have their systems pen tested because it's money. It's your money. You want it to remain in your account unless you're spending it. But that's intent. Okay, so how do we test our own apps once they're in the store? You can obviously ask your dev team to give you the APK. You can submit it to a company that will do it for money, or you can play around with it. But we don't need to test our own apps. We might want to take a look at others. So For instance, you're developing a feature and you know that Facebook or some other company made something similar that looks very nice. And you might think, okay, I can take a look at their code maybe a little and see what they used. I mean, mobile development is generally not about reinventing the wheel. We don't want to create from scratch because somebody else spent time and effort and had problems with, I don't know, HTTP clients or libraries for image loading and caching. And unless you're bored and your company wants to pay you for, playing around, you usually need to be quick and you need to produce something tangible very fast. So you might want to have, let's say, global code review with some other developers that you might not know, but that's for you to decide. Okay, so how do we take a look at somebody else's app? We can produce our own APK, or we can just take it from the build folder, but how do we get others? So it turns out that on Android, getting anything out is fairly easy. If you want to get an APK for any of the applications, you need to know the name and the location. And to get that, well, first you need to decide which one you want to get. The shell order is adb shell pm list packages. Now, for those who are not Android developers, and there are many of you or none of you here are, once you install Android Studio, that's the tool for development, you basically get all the tools with it. So you don't need to install 50 applications and tools and prepare it at great length. Basically, once you install Android Studio, you will get the SDKs and the tools with it as well. So there's a list of the orders that you can execute later on in the presentation for those who will want to explore. So by this, you can list all the packages that are currently on your device. Now, if you want to, I don't know, limit that to Samsung applications, so this is actually the printout from a small Samsung device, because if it works on a Samsung, it will most likely work on everything else. So that's your go-to-buy device if you need to test Android. Here you can basically look and choose, okay, I might want to take a look at this particular package and see what the name of this application is. Now, to do that, again, you adb shell pm path and you give the package name. Now this will give you the path to the application and the name. And here you can say this is the location and the name is Samsung Video Player Dream Preview APK, because we don't have enough video applications on our phone or to download. Now, if you need to get that application on your device, on your laptop, on your PC or your MacBook or whatever, you have the adb pull and you give this full path and you say where you want it to go. At this point, you have retrieved any APK from your mobile device to your PC. So this probably took like 2 or 3 minutes, just basically took more time to install Android Studio and get the downloads from that. But basically to set up testing and retrieving of Android applications, it's ridiculously simple and it takes very little time. So once you have the APK, you need to know what to do with it. Now, an APK or an Android package kit, it's basically like a glorified zip file. If you change the extension, you can open it and take a look inside. And if we take a look inside, you can see that there are different folders here and some other files. We won't go into details because these won't mean much to you. The most important part here is the Android manifest XML. So that's a file that every Android application needs to have. And this is where you declare all the screens that you need to display. You declare permissions that you need to request from your user. You declare any kind of broadcast receivers, etc. Basically anything that's more important, it will be defined here. So if you need to check for some particular feature, or if you've downloaded an application for images and it's asking you the phone permission, then this is the first sign that the application might be dodgy, because if it's just displaying images, then it probably doesn't need to call your friends. So a good way to check whether or not something's critical is to take a look at the Android manifest. So the tools that we can use to take a look at the content of an Android application, there are quite a few of them. Again, some are commercial, some are free. The first 3 are at your disposal, maybe even the 4th one. So we will just briefly go through them and see what they can help us with. So the first one is APT. Now it's an Android asset packaging tool. Great name. And it does what it says it does. It packages assets. Assets can be anything. It can be images, strings, colors, anything that you have displayed in your mobile application. It will be listed in one of the XML files in the assets. And what it does, it can give you insights into the application on, again, what is being used. Now, if you use APT list and the APK that's being looked at, you get, again, the list Android manifest XML, and you get lots of different stuff here. Now, everything that's within the assets, again, it's some JSON that you added. It can be styles. It can be any kind of layout. So when you look at the Google the Mail app, you can see the forms for the to, CC, and the rest of the fields, the big form to input. It's all defined in the layouts. It's what's displayed in the screen. Again, drawables, any kind of image that might be used, a 9-patch, PNG, whatever it is that you have in your app. Menu, so basically if you have an overflow menu somewhere in the app or something else, it's basically all defined here. Again, XML for anything more dramatic that you might need, but you get a list here. You can use different, I don't know, additions to the command up there to get more info, like -v for structured view, -a for a more thorough detailed view. Now, again, if you want to take a look at contents, you might use apt dump strings. So any kind of string in the package, you will get it listed here. Now, this isn't really interesting because it just lists all the references that are available. But if you take a look at apt dump XML strings from your APK, more specifically in the Android manifest file, now you're getting to the important stuff. And now you're getting to the whole structure. You might know whether or not your application is installable on your SDK, on the outside of the system, on the SDK card, or just internally. So basically, some Android phones have a problem with space. So some applications allow for the application to be installed outside of the system. Version code, version name, that's just what's displayed and how they know which version of the application is installed. Min SDK and target SDK. This is usually an indication how many users your application targets and how big that user base is. And also target SDK, this has to be always on the highest number for Android, which is 28 at the moment. And it basically says that this application is optimized for the latest Android SDK that was released. Name, protection level, this is all information that you might or might not find useful depending on what you do. And if you want to just take a look at the permissions, then it's dump permissions from the cool APK. And this gives you kind of a glimpse into what the application does or shouldn't be doing in the worst case. So maybe it will send you messages and it needs to vibrate. It will read phone state. This might be, why does it need to read the phone state? Camera, call phone, internet, basically this requires everything to be present, and it could be a problem. Again, you need to match these to the application that you're using, whether or not this makes sense. Now, you can learn from this, but if, I don't know, command lines aren't something that you enjoy doing, Android Studio kind of helps you out with that. You can just use the Android Studio APK analyzer that's built in, which will give you all the info for the APK from the get-go. So basically, you can take a look at this XML file and just see the info that you want to look at. So we can take a peek inside, but can we change it? Can we modify it? Of course, the answer is yes, because why make things safe and simple when they can be chaotic and problematic? So it's actually extremely easy to modify an Android APK, the ones that you have installed on your device. For instance, if you want to add something like a file, you can use apt add -v. So you list the APK that needs to contain the new file, you tell it where it needs to go, and you just supply the location. So once it's added there and you take a look at the content, you can see that it's listed under assets. So again, one command line and you've added something to the APK. This can be something random, something that you might use later on, something that will be present, I don't know, from an A/B testing standpoint. First it's not visible, and then when you did flip some switch on the server side, it might become visible. So you have options to do stuff with it. Again, if you want to remove something, again, apt remove from the APK what you need to remove. And when you list after that command, you'll see that it's no longer present. So what happens now with the APK itself? We added something, we removed something, let's try to install it, because if we cannot install it, then what's the point of everything? Turns out Android actually takes care of you at this point, and it keeps you safe. Once you modify the APK, it's no longer the same. The certificates are not the same. For just to clarify, each Android build that you install on your phone, it was signed by a particular certificate. That certificate belongs to the private entity that created the APK. Now, if something changes, somebody else tries to sign it, it won't have the same signature, meaning that if there's a fraudulent application, same name, same application path, everything is the same, but somebody altered it and published it on a website, you won't be able to install it. First of all, because Android won't allow you to install from outside sources, and the second of all, you won't be able to match the signature. So the signature needs to remain the same, and if you install from Google Play, then all your updates will come from that channel. So this is a good thing. But that doesn't mean you cannot sign it anyway. You can sign it with your own certificate, and this is problematic. We will get to that later because of phishing. But yeah, so you can sign it, and after that you can install it, but not if it's already present on your device. Now, what we have like a second tool, which is also very, very useful, is APK tool. It's a tool for reverse engineering. It can decode from a nearly original form, and it's more useful than what we were using right now with the APT, because it recreates the structure that was in the application. Just one reference here to use. You need Java 7+, so yeah, people keep those levels very, very low. I don't know why, but doesn't matter. You can download the jar, you can use a wrapper script, so there is some work with it, but it's usually done within 3 or 4 minutes. And you can, after you're done with this, you can run it from your terminal. So again, we're in the terminal, we're doing work there. And once you set it up, this is what you're going to get, like a full list of options, which are overwhelming, and you don't know what to do with them. But there's also a manual, so you can get started with this if this is something that's interesting to you, and you're ready to go. Now, a reference here that you might want to take a look at, it turns DEX files to Smalley. Smalley, it's basically something of an equivalent of assembler, disassembler in Icelandic. So it's a specific thing to read, but you can learn it easily. And the easiest way to learn it is to take a small application with just one screen with no content inside, and then Smalley it and take a look at what it turns out to be. So you can learn to map those things between them. If we use the APK tool on our application, you can see that it will Smalley most of the things, decode, copy, etc., and you get the structure that's more similar to what we had from the beginning. And now, if you take a look at the Android manifest file, you can see that it has the exact same look that it had when you were creating the APK. So this is huge. It's huge because this is readable and this is simple, and basically if somebody's doing this to your app, they will have everything laid out. Now, again, if you take a look at the layout files, this specifically is a linear layout somewhere in the app, so it's one of those screens. You can see that it contains a web view, so you might want to poke around for that screen, what it's loading. Is it a URL from the outside? Is it local HTML? There's places to go from here, and it's problematic. Now, if we want to rebuild our APK, again, if we change it, if we modify it, we might want to see whether or not we can install it. You just need APK tool build dot, and it will rebuild our APK. Now, again, you cannot install it because it's lacking the certificates. All was stripped while you were modifying it, and you need to re-sign it before you get to the installation. Again, if you have it installed on your device, you won't be able to upgrade because obviously the signatures don't match. But if you were to, I don't know, use it somehow, you know that it's fairly simple. It has one problem. It might not work on all the instances. For instance, it's missing particular framework files. I already said that Android has like a lot of SDKs, and for specific devices it might be problematic. But this is a bridge to cross once you get there. And how big of a problem are modifications like this? They're a huge problem because you might be tech savvy and your users might be tech savvy, but I guarantee you that there is a portion of the population, older population, that if you put up a phishing site from the local bank and say, please download our new application here and you will get free membership for a year, there will be people who will click on it and install. So what to do from there on, that's a different thing, but yeah. So you need to think about that, and if your application handles, security or money or finance, things to check are basically how exposed your application is to the world. Another tool that you can check is Classy Shark. So it's whimsical, it's funny, and it's quite powerful. It's easy to set up. You need to know Python to use it. So if that's your fancy, by all means. You can browse components, you can expect your application, you can do a lot of things. But again, it depends on you whether that's something that you would like or not. Another tool is AndroGuard. Sorry, this is the full Python tool to play around with Android files. It's advertised as very, very powerful. It's advanced. It has many options. So if you want to use this, read the manual. It will be very, very beneficial, and it's ideal for reverse engineering and basically malware analysis. So if you have an APK that you know that's probably malicious, this is a good tool to check it with. It's fast, which is usually beneficial in situations like this. So if you need to check something, this is something that you need to do. So Python Androlize by the -s, and it will analyze the cool APK and put it in something called A. And from this point, you have a list of commands that you can execute on that object A. For instance, get main activity will list out what is the main activity. Main activity is the first screen that you see when you open an Android application. So it's either a splash screen or a welcome or some kind of form or whatever it is. And once you do that, you can use the tab like autocomplete to get different information on the APK. So whether or not permissions, services, receivers, etc., anything that might basically lead you in the way what the application is using, what it's communicating with, how it's storing data, etc., etc. Now, the next tool is one of my favorite. It's Charles Proxy. Now, we always think about our applications and use from the standpoint, I mean, from my standpoint, it was developers. So I was in my office, I was on very good Wi-Fi or on LAN, and it was fine because we had good Wi-Fi. But if you release your application and somebody goes to an area where you have edge, then things might break. There was a good offline first talk today, which I hope you heard, but you need to check how your application responds when you cut the cord to the backend if you have it. Now, what's very good for this, it's an HTTP proxy. It will read and view all the traffic between the client and the internet. And it has a trial, which means you have to pay for it later, but I'm sure you'll be able to find a way around that if you want. Or, of course, you can pay. The best feature of all is playing man in the middle. Now, man in the middle is the simple attack where there is obstruction in the channel between your device and the server. And that particular problem is that it can eavesdrop on the information being transmitted, or it can alter it. So it's a huge, huge problem. And this is what you can do with Charles Proxy. Basically, view all requests and responses in plain text and shuffle them around. From Android N, Nougat, a feature was introduced, the network security config, which allowed you to display all the certificates that you will be using in communication with backend servers, meaning you would kind of eliminate the man in the middle problem because your application trusted only specific backends. But again, we learned that we can modify our applications. So if we were to go to the Android manifest XML and change this little line here to point some kind of different network security config, one that would allow system and user installed certificates, then we've just gone around the whole certificate pinning that we had in our application. So the other features that we have are bandwidth throttling, requests that are being repeated, and intercept and edit. This is all important because basically if you make a modification that the JSON that you're expecting from the backend server is changed from true to false, not much will break because this is kind of data that you expect. But sometimes backend developers tend to go wild and make mistakes, meaning that they might send an empty list, which you're not expecting. Will your app break? Will it cause an exception? Will it cause a crash for all the production? You can test this now, simple, without it going to production by modifying the requests. Also, if you're shuffling, I don't know, username and password in the requests, you might see how your app reacts to different content or maybe intercept and steal stuff. So things to look out. And finally, one thing, or actually 4 things to leave you with, reasons to reverse engineer your apps and test. You need to have a tool for simple learning and checking, and sometimes you can learn from the giants in the industry that have already created something beautiful. So taking a look at their code, open source or not, might be beneficial to you. You can detect leaks and basically oversights that your developers are not thinking about, which is a lot because there's a lot to do, and requirements are not often very simple and straightforward. You can proof your app. You can add temper detection and other things in it by trying to temper it, and finally you can use commercial solutions as a fallback if this is something you don't have time for. But I can promise you, whichever tool you choose to use or try, it will be beneficial to your team, and I'm sure they will be grateful to you for helping them create a better product in the end. So, thank you.